Okay, hello everyone. Welcome. It's October 2022. We're having our monthly forth meeting, and there's an interesting schedule. Let me see. Here we go. Yeah, this is our schedule. We will have interesting talks, and I'm very happy to also see lots of demo time talks that will give hands-on presentations of things, so not just slideshows, but where you can see things in life. And yeah, without further ado, I will hand over to Peter Jakacki, and I'm very happy to learn about the P2. I've been following that for a very long time, and now we get firsthand a report and demo of this interesting chip. So Peter, please go ahead.
Now, are we swapping around? Am I swapping around? Is it Hans? Am I swapping around? Somebody's going before me?
No, we don't.
Oh, okay. I thought that's what we were doing before. That's all right.
Yeah, sorry.
That's all right. I'll just fix this up here. Something just fell down, as it does. And I don't know why it does, but it does. Yeah. So this goes straight demo on the P2. Now, what I'll do is I'll share my screen here, and what I'll try to do is I'll try to make this as big as possible. I'm just doing standard 1920 1080, but I'll do a quarter screen, see how we go with that. So let's see. If I go advanced portion of the screen here, and I'll just share this corner of the screen here and see if we can adjust that. Now, that needs a bit of adjusting, doesn't it? So I'll just stop that for a moment. Sorry about that, and get this set up. We need to get this set up before the meeting, actually, but okay, so here we go. Advanced portion of the screen, and what else are we doing here? I'm trying to remember how I adjusted this, that's all. Anybody remember how to adjust the portion of the screen here? I haven't done it on this one here. I forget now. All right, well, for the moment, I will just share this part of my terminal window at the moment, just to, no, actually, I really need to share everything here, so I'm going to get this correct. So just give me a moment. Portion of the screen, and I share that, but I don't know quite where it goes. Computer. Sorry, does anybody know with sharing Zoom portion of the screen? There was one little trick, I missed it. I forget what it was. I don't do this often enough.
It's working, Peter, now. Okay.
Yeah, okay, I'm just trying to get this, you can hear me okay, so I'm just trying to get this portion of the screen adjusted here. So obviously you should be able to see this part here. So just bear with me for a moment. Okay, because I can't see quite what's being shared. What can you see at the moment? Can you just see part of the terminal window, or
part of your screen?
Yeah, only part of it, it seems.
Yeah. How do I adjust that window size again? I'm trying to remember. There's some little trick to it. Remote control, more. Here we go. More. Enable. I'm really going to, I really need to adjust the screen size, and I can't seem to do it. I can share the whole screen. That's the only other thing I can do if I can't do this. So.
If you do the screen sharing, then there's another tab, which means says something extended or something like this. Yeah. And there you can choose share part of the screen.
But that's what I'm doing. I'm just trying to adjust the size of that. How was that again? They can't see where it is. I found it last time, but I forget. Sorry. Do anybody remember? No. There's portions of the screen I can share, but I can't seem to see where I can adjust it. I'll just have to ask. You have to bear with me for a moment. So Zoom share screen portion. Adjust.
So you could share a single window probably if you press share and then choose one window.
Well, what I want to do is show a few different windows. I want to be able to drag them all into that same area. That's all. And to resize it, simply click and drag the perimeter. Well, I did that. Well, I'll try this once again. All right. So I'll try this again. I thought I tried this before. Click and drag the perimeter. That only moves it around. I'll try this part of the perimeter. Oh, okay, there it goes. Finally. All right. Didn't seem to work before. Okay, so you can see all that. Okay, good.
Yeah.
All right.
Yeah.
What I'm going to do is, so you can see a picture of the board here. You can see that standing
Yes.
in the middle of that. Good. That's what I want to be able to do. Just drag down so we have yeah, enough here, and also the oscilloscope we can see here. All right.
Yes.
Okay, very good. And also to the VGA output that I have from that board as well.
Yes.
Okay, so this is good. So what I might do is I might just leave that one up there for the moment there, and just show you very briefly. I'll tell that to stay on top so that it stays there. Stay on top. All these windows in the way. Okay, always on top. Okay, here we go. So I'm going to put this down here. I'm going to reset this Tarkos I'm talking to, which is the tachyon forth that I have on the P2 board, that you saw in this in the camera view just there before. So I'm just using the evaluation board that I originally had, and I have an extra adapter on there. That is just feeding into a little capture device instead of a monitor, so we can move the screen around here. As you can see, whatever came up on the terminal window also came up on the VGA window. I'm going to switch across to VGA, and there we are. We're talking on the VGA part of it right there. That looks okay. Let's have a look at the directory. Just a few little introductions to using Tarkos on the P2. So I have full FAT32 file system in here. I can view one of my splash screens, minion up there, etc. Go negative on it. Why not? I can also change the resolutions on here as well. For instance, if at the moment, this is set to 640 by 360p on the VGA, and the video DACs are built in. So on the P2 board, I don't want to spend too long on this, but I'll just show you the P2 board. I have the VGA connected directly, the RGB connected directly to I/O pins, and those I/O pins already have the 75 ohm, everything else, the video DAC's built in, and the palette I can build in right into the actual COG memory. There's a memory there I can use for that for quick lookup. So all very simple to generate video. In fact, it's that simple that I can come along here. I can say, look, I don't like this resolution. I want something really low resolution, 180p. All right. But when I do that, I'm going to tell it to clear the screen at the same time. So hopefully, yes. So now I've gone really chunky. I can go even chunky again. I can't remember quite all the settings I have in here, so I'll just double check what I've got here. Just taking you through a few features. I can manually set this, but let's set this down to 18p. All right, so try not to put it in the wrong place. 18p. Where am I? Over here. I've got to remember which window I'm on. 18p. But I'll clear the screen so it resets everything up there, and I should possibly. I don't think the VGA capture device will show this particular one here, so I'll just reset all that again. But you get the idea. I can go right up to 1920 by 1080. So, for instance, the capture device is very confused now that I've done this, but that's what happens. So let's set this up to 1080p. It'll go monochrome for 1080p because of the memory requirements, etc. for it. And VGA, switch over, clear screen. All right, so there it goes. And there's something else I need to adjust in here. I've forgotten about it, so I'll just go back to standard. I'll just reset again. Okay, I don't want to show you too much with the video, but just wanted to just bring that in here. I'll play a quick movie. It mightn't be the right speed or anything else and so on. I'll just say play TV. There's one in there called Tribbles, little clip. So I'll just play that. Oh, and it's a bit fast. Sorry about that. But you recognize it, don't you? So this is just reading straight from the micro SD card. I've got it synced in such a way that I can read straight from the SD card straight into the frame buffer, if you like, because we don't have enough memory. really to have a separate frame buffer, etc. So that's just something there. Media stop, I think, I can't remember what it is again, stop media, or just reset. Sometimes just reset works really well. Okay. Play audio. Let's play audio. Let's play the Taco's device startup as well. Now, what did I just do? Yes, okay, I'll fix this up. Play Taco's, a bit of audio. This will just play a WAV file. I can turn that up, right? You can hear that okay, I think. I can turn that up if I need to. But what I will do now is change over to here. Play some other music, etc. So we can change all that, pause it, etc. Do that. So there's a couple of little quick little things. I hope you can see that well enough. But now I want to show you how we can generate signals from the smart pins, because we have a limited amount of time for this demo. So as you remember, I'll get the video part out of the way here. As you remember, we've got the board hooked up. I've got 4 scope probes hooked up, and they're hooked up to pin 16, 18, 20, 22, just so it's easy to hook up the probes on here. We can see the traces on the screen up here, which I'll bring across. You can see that. I'll just make sure that stays on top when we do this. So, okay, stay on top. Right, so we've got it staying on top. We don't need to see the picture of the board anymore. And what I want to be able to do is say pin 16, set up pin 16 and tell it to output 10 kilohertz. Okay, no biggie, there's 10 kilohertz. Pin 18, make it 20 kilohertz. We should get things on there. So I can put in pulse width modulation, etc. For instance, I'll just do another one with pulse width modulation on there just to show you what's possible out of that. There's a few different modes. I haven't been using this for a long time, so I'll have to remember how to use it all. But essentially, what I can do is I can come along and say, okay, here's my duty cycle that I want in a certain frame rate. So if I say 20 out of 100 in a frame, so 20% with a division of 1, so the highest frequency we can go. Whoops, I'll just do that again. So 1 and PWM. But before I do that, I better select the correct pin. I'm going to go 20, pin 20 and PWM. So there we go. We've got, that's a fairly high frequency up there. So I'll slow it down a little bit just so you can see that. And I think this, I don't even have to do 20 pin anymore, but I'll just do that. Okay, it's still very fast. And with this remote I have on here, I can zoom in on it, I think. I'm just trying to remember how to zoom in on it. It's one of these little tricks over here. Level. Okay, here we go. Position, scale, here we go. This is the right one. One of these ones here. There we go. Bit better. Pull it down a bit. And there we have a 20% duty cycle happening on there at a lower frequency. We can speed it back up again by going 2100, 1 PWM, and 20% back there again, drop it back down, drop that back down to 10%, and slow it down again as well on that pin. We've got 64 pins. What I can do is I can come along and say from pin 16 for the next 8 pins like this is just in Tacos. I can say, look, make all of these generate a 30%, and I'll use the same scale once again, PWM. Okay, so let's see how this works. Fingers crossed, there it is. So we can actually span a whole range, set them all in the same mode, synchronize them up, set them high, low. There's many different modes. We can even come along. For instance, I might pick the last one down there, channel 4, so that'll be on 20, and I might even say, look, do something a little bit different. Put out 1000 millivolts. I think that's the correct term I've got in there, isn't it? I'm doing something with it, that's for sure. I'll have to remember what I'm doing on this one here. Millivolts, volts, millivolts, and yes, I just had the wrong term in there, that's what I did. So bear with me for a moment, I'll bring it back. And this time I'll just say 16 pin, 100 kilohertz. There it goes. And now 18 pin, I'll go the next one down, and I will say 1000 millivolts. I think I've got that right now. Okay. So did that move? It should have done. All right. Okay, it should be moving. I don't know. I'll try it again. 2000 millivolts. Anyway, we have there it goes up there. So if I get the meter on there and I want to set it to 2275 millivolts, well, that's where it will go. If we measure that, I've put the meter on there now. So that's just all done in forth. What does it look like, millivolts in forth? Well, let's have a look at the definition. There it is. 22 bytes basically is setting it up for that particular mode there, and into a 12-bit DAC mode as well. There's lots of different modes, A to D modes. There's all kinds of async serial modes. You know, we can get really, what we can do with this is we can set up one of the pins set up for 20 megabaud, no problem. How many bits? 8 bits? How about 18 bits? 32 bits? Doesn't matter. Completely flexible. It's a smart pin, and we just set it all up. We're not assigning a peripheral to the pin. The pin is the peripheral. One of the things about this. Now, there's so many things I forget to show. So if you have any questions while I'm speaking, please just ask me. All right. So any questions at the moment? I just want to make sure I'm still connected too. How are we going? Am I still connected? I've lost my audio, I think.
No.
Still
working.
working.
Yeah, we're listening.
Oh,
We
yeah,
have a
no,
question from Ben Sherry on the chat.
okay, yep. All right, so I'll just have a quick look at the chats there. It's a bit hard when you're sharing. I normally keep this on 2 computers. I was trying a bit different this time. So the question is, sorry?
When are you going into production?
Look, you know, I really wanted, when I first did the P2D2 module, which I'll just get out now, one of these modules, etc. Original P2, you know, but anyway, all these P2D2 modules, I really wanted Parallax to produce it because that was natural for them to produce these modules.
Peter, my
Yep,
question for you is why you can't be normal and use C in spite of force?
So in spite of forth, no,
Yes.
no. Okay. I can tell you that. Look, what I'm doing now, I'm only using a tiny percentage of the memory. What I've seen everyone else try to do when they put MicroPython to this processor or put, you know, get C compiler working and so on. Or it doesn't matter how much memory you have, it seems to use up all the memory. MicroPython only runs on one core, you know, the one of the cogs, and it's slow. And what can you do with it? Yeah, sure, you can import modules, but you're still limited. Here, I'm running all of this in one tiny corner of the 512K of internal memory. I'm running it about less than 64K of code, in fact. And so not only do I have the compactness, I have the speed, but also have the system on there. If, for instance, like I come along here, I even ported my editor back onto this one here. So if I bring that up now, for instance, and I'll try to do this with a smaller size screen or something rather. I think I have to pull this back up again in size, but okay, I can have a screen editor built in, even just operating directly on the files. This one doesn't have, sorry, I'm mucking about with this at the moment, but the thing is that what we have here, I'm just trying to think what this is doing now. I know what's going on. I'll just fix this up right at the moment. ET, put it back in ANSI mode and check it there. Okay, doesn't matter. I'm just demonstrating at the moment, but the thing is, I've got the full development tools on here. It's very interactive. I've discovered how to make things work the way they shouldn't. Even the speed of the SD card, for instance, I couldn't directly do that from within the smartphone peripherals, but I did use them, a few little tricks in there, and the sort of speeds that I'm getting out of it now are like, I'll see if we can bring this back up again to the right size, back into the screen. Okay, it's getting a bit small again, isn't it? So I'll bring it back up here, just make sure that this terminal's in here so you can see it. Bring it down there. Not quite in the right spot, is it? So just bear with me for 2 seconds. Okay, there we go. So what I can do is just show you that when I'm talking to this, it's doing a speed test on here, for instance, and what you can see over here is that it's reading at a speed of, when did I have it over here? Okay, that's not really running as fast as it could do on this one for some reason, but I can get about 8 megabytes per second read speed, and that's, I'm not even trying hard at the moment, really, just a few little tricks. And I've got full formatting utilities, everything on here for really testing out the SD card and being able to interact with it. I'm a hardware guy. I'll say that, even though I write lots of software, but I've never liked software that isolates me, insulates me, and abstracts me from the hardware itself. You know, working, it's like I want to be able to optimize it fully. You know, it's a bit like Steve Wozniak. You know, what did he do for disk controller? He didn't use any of those floppy controllers around. He came up with a totally different method. It was really cool, right? Basically, I want to be able to tweak that hardware, get the most out of it without consuming all the resources. And a lot of the other guys I know with P2s, they're adding extra memory on, which is on I/O pins. You know, anyway. So that's what I do with this, and I originally had it designed to go into a product a couple of years. Well, the P2 wasn't quite ready at the time. I'll just show you very quickly. What I've got is, this was the final FPGA version here, and it used a BE Micro CVA9, so it had a nice one on there. I could actually have 16 cores, 1 megabyte of RAM, everything on there. But I used that for development and did the final ROM and testing and everything else and so on with that. And so with this particular P2, I have Taco's forth in ROM. It was the only thing that could fit in ROM that was actually useful. A monitor is not very useful, but forth allows me to get in there and debug the hardware, exercise it, do these timing signals, everything with basically just a chip. That's it, and a serial terminal. So I originally did the FPGA version, and then I had a board that the CVA9 plugged into, and that connected over a network over to all these other boards, which were hooked up to 2000 amp SCRs essentially, and in a 3-phase system. I had about 40 of these devices and that in there, but P2 wasn't available. You know, I was still working out of FPGA, so I couldn't really proceed with P2 on that particular project. So I've got lots of different projects in mind, but I like to use lots of different micros too. P2 is sometimes I call it the beast, and it is a bit of a beast in that it's a big chip, and it can get power hungry. 1.8 volt and 3.3 volt supplies. I can draw about an amp. You know, it depends. You know, if you're running, you think of 8 32-bit processors running at 320 megahertz. Yeah, you know, they're going to draw a bit of power. So, but you've got a lot of flexibility, a lot of power, and it's still a microcontroller. It's real time. You can set up a processor just to handle one little thing really well, along with the smart pins, and still doesn't affect any other part of your application. Never happens with any other processor. Interrupts, applications, real-time latencies, always a problem. Total nightmare. This one is not. Very clean. Anything else?
Amazing.
All right, thank you very much. Are there any questions to Peter? So
yeah, I wanted to ask, is this open source, and can you download that somewhere?
Yeah, yes. You know, I've always had, right from the beginning, I've always had all the files on Dropbox. I've got them on SourceForge. I've got some on GitHub. I don't really use GitHub a lot, but I've got them a few different places. But all the tachyon, P1, P2, even the work I've been doing on a few other processors, including the Raspberry Pi, the RP2040, all that is in Dropbox. I can put that up on the chat, and it's also on forth-2020. We've got a site there too, and it's got a lot of links in there as well. So all the information about it, etc.
Thanks.
Okay. Are there any questions? Others?
I think Christian will try one.
Yeah.
Are you there, Peter?
Sorry?
You hear me?
Yes, I can. Yes.
Okay. With all others MCUs that I've tried, I had to, when I wanted to do many things, I had to use multitasking or interrupts or chain things in one program. But with the propeller, they had figured out a way of doing many things at the same time because they have many processors. But how do they do the sharing of hardware?
Yeah. Good question. I've seen some processors, multi-processors, but they don't really share. All the I/O are completely common to all 8 cores. Any core can access an I/O while something, etc. They can do that. The hub memory 512K is totally shared. It's shared in a very clever fashion. You think, you know, the original propeller had to wait for its little turn to get part of the hub timing, but this one works quite differently, and so it can be very fast. And in fact, we even have streamer logic in there just to stream straight to and from the hub memory. There's each core, each cog has 2K, well 4K really, 4K of memory local, which can all be registers. But of course, where you put code in there, and if you want to, you just want a simple bit bash task, it can just sit there, do that for you exactly the way you want it. And the other thing is the P1 never had interrupts because it was dependent upon the cores to do all the little tasks. But the P2 allows for interrupts. And in fact, on mine, I run my serial receive under interrupts. You know, I don't need to, but I do. And there's quite a lot of things for debugging and everything else you can do with those interrupts, very clever things. But the fact that everything's shared, well, the I/O is, every core is identical. You know, the RP2040 Raspberry Pi, 2 cores, but you know, they don't make it easy. It's a mess. Whereas this is clean as, and I can come in here and just create a new task running in another cog, running at full speed, and doesn't impact anything else.
Thank you.
Thank you.
All right. Other questions? Well, Peter, then thank you very much again.
Thank you.
And our next speaker is Hans Bemeier. And you have to unmute yourself, and then the stage is yours.
Okay. Can you hear me?
Yeah, we hear you and we see your slides.
That's fine. So that's not really a slide. That's just from the data sheet of the CH59 is a RISC-V microcontroller, which has quite some outstanding features. So the biggest feature is its price, which is only €5 in single quantities. And this is special because it is a USB 3 super speed microcontroller. So it has USB 3 functionality. It also has USB 2, of course, because that's a part of the USB 3 spec. And it also has a 1.2 gigabit SerDes peripheral, but which can only work in one direction, input in or out, that can be configured. And then it has also standard peripherals like timers and SPI and PWM. And then you have 4 UARTs, some more SPI, GPIOs, eMMC. And the CH569 has a high-speed parallel interface, which is a parallel port 32-bit wide at maximum 120 megahertz, which can deliver about 3.8 gigabit per second to FPGA, for example. But that's only half duplex, so the bus can only work in one direction at a time. But this can be switched during operation, but it's half duplex. There's also a digital video port, but not in the 569. That would be in the 565 chip, which is a variant of this chip, which doesn't have the high-speed parallel interface, but a digital video port, which is something like an RGB VGA type video port. Yeah, so this is the chip. And I made a little development board for it, which is open hardware. It's on my GitHub. And so this is the newest version. So here's the SerDes, and here's the UART, and here's the parallel port. And yeah, let me switch to my camera. Where now I've got to find the Zoom window somewhere. Do I have to stop sharing for switching the camera? Let me stop sharing for a second. So I switch to the board. Now here we go. It's turned off at the moment. Now I'm going to share my screen again. Where did the window go? Right here. So, okay, can you see the editor, the text editor I've opened? Okay. So, and now let's turn this on. I have a ST7735 display connected to it. And so there's a little debug and serial adapter. And now I turn on the microcontroller. Okay. Did the video just freeze? Okay, no, seems. Okay, so now let's connect to it. So I run the serial at 500 kilobaud, and I use eForth-com. Okay, here we go. We've got Mecrisp Quintus ported for this chip, and yeah, I wrote a little bit of a board support kit also for it. So I have written drivers for GPIO. GPIO, they can do, yeah, the usual stuff, LED blinky included. Then I've written an SPI driver for that board, which is used with a ST7735 display, and also a driver for SPI flash. And what else? Also for SerDes driver, which I didn't test yet. And but the most important thing is, yeah, later. So my daughter came in. So the most important thing is flash. So the internal flash programming I wrote also in Forth, and so here there is a flash.fs. So this is, wait a minute, let me open this. So this is the driver for writing and erasing the internal flash memory of the microcontroller. So this allows me to burn the dictionary into the flash permanently. So this is a bit special on the CH59 because as you can see, here's ROM and RAM-X. So RAM-X is the super high-speed SRAM, which is used for all the high-speed peripherals like USB 3 and so on. And the ROM is actually shadowed or cached in that RAM-X. So you can choose how much of the SRAM, which is total 96 kilobytes, or 128 kilobytes, you can partition them, how much is used for caching the ROM and how much is available as RAM for DMA for the high-speed peripherals. So I use kind of 64 kilobyte. So the thing is, if you don't run the ROM code in SRAM, then it gets 8 times as slow. So the 120 megahertz CPU downgrades to about 16 megahertz CPU, if I remember correctly. So this is 12 megahertz CPU. I cannot calculate in my head if I'm talking to somebody. But yeah, it gets 8 times slower, so it's not exciting. So a nice sweet spot is 64 kilobytes of flash cached and 64 kilobytes of RAM. So that means this will be available for the flash and RAM dictionaries. Okay, let's see how this works in practice. So what I did is I have this driver for the internal flash. And what and this is kind of the hook word that writes into the flash. And I'm cheating, which means I'm just writing to it because it's SRAM and it works, but that doesn't mean it's in the flash yet. So and so I have here. I also the microcontroller can only do full 32-bit word write. So, but the Mecrisp forth for the flash hooks needs a half-word store. So I have kind of to emulate a half-word write with 32-bit writes. And then there's save to flash, which is, programs the whole flash dictionary into the ROM from the SRAM. And the erase flash erases the flash dictionary. And now let's see how this works. So I made a little bit script to build the flash dictionary. So in order to use the flash, I have to include flash hooks and then switch compile to flash. And I didn't find out why this happens, but when I do compile to flash, the flash hooks in the dictionary is gone and I have to load it again. And then I load the GPIO, the timer, and SPI driver. It's just a lot of random stuff which I want to have in my flash dictionary. I have also ported or included other forth files from the Mecrisp distribution like multitask FS, the disassembler. I also wrote a dump FS or with which you can look into the memory. Also I ported from the GD32 microcontroller Mecrisp. I put the graphics examples. I ported it over to my microcontroller. And okay, let's see how this works. Let's go to the console, and I include the build flash dict fs. And now, yeah, it's loading all the words in all those files. Oh, great. Yeah, wait a minute. I need a space here. Let's do that again. So what this does, it loads all the files, and then at the end, it does save to flash. So it programs all that in flash, and this happens right here. So now it's programming the flash memory. So the flash dictionary, which was cached in the overlay SRAM, gets written into the flash, and then it does a reset, and then we have the full dictionary inside running from the flash memory. Now that takes a little bit. Yeah, so the forth libraries I loaded, the words are almost filled the 64 kilobytes, so that's quite a bit. And you can see here in my, oh, okay, my camera froze. That was unfortunate. I probably have to restart Zoom in order to get it working again, which is a pity. Oh. Let's see if this works, if I switch back and forth to, oh yeah, okay, it works, nice. So I share my screen again. So you see here the graphics demo from the Mecrisp forth runs, and if I press Q here, it stops. And I can do something like color demo. Wait a minute. Oh, color strip demo. Now I've got some color bars or turtle demo. So turtle graphics. So those are the words. And so let's see flash the words which we have. That's quite a lot. And let me scroll up. Is the font big enough to be readable, or should I? Okay. So this is a flash dictionary, starts at 5,000 hex. And here are all the words which I programmed in flash dictionary. So as you see, if I do reset, the whole thing starts from the beginning. And I programmed the image in it, so it runs the graphics demo for this example. So let's press Q again. So this has really been programmed into Flash. Yeah, now if I don't want the graphics, for example, I can erase the Flash dictionary with erase Flash, and then we can see it's gone. And if I now say words, then I only get the built-in words, but here when the Flash dictionary starts, it's empty. And I could, for example, choose a different set. I could turn off the graphics here, and I could include the disassembler. Yeah, let's do that for once. Now it's writing the Flash dictionary again. Oh, I probably should have. Oh, no, okay, that's fine. Takes a little bit. Yeah, so if you have any questions, don't hesitate to ask and interrupt me. So here we are again, and now I can say something. I've got a little word where I can choose the number of columns. So this is the standard dictionary, and here starts the Flash dictionary, and we see again, here are all the words, and I also have a nice utility. For example, ramx is the SRAM, and I could, for example, say ramx inspect, And then I can directly look around here and look what's in RAM. And I see, oh, here's the Flash dictionary, see the names. I could, for example, also, I could do something like C X dot, and then I have here the disassembly. I didn't write that, so I took that from Mecrisp, but I wrote the memory dumper. I took the part of the memory dumper from Mecrisp, but I wrote the inspect word with which you can kind of interactively go page back and forth in RAM and press quit if you're done. Yeah, and I think that would conclude my demonstration so far. I still want to talk a little bit about the CH569. So, the biggest strength is its very low price for a USB 3 microcontroller. This is pretty much the cheapest USB 3 super speed microcontroller available by a large margin. So the next step up would be a FTDI, which costs about twice the money, and but it only can do bulk endpoints, and it's also probably not as fast as the high-speed parallels interface of that one. The biggest weakness of this one is the Chinese board support package, especially the USB 3 super speed driver is only a closed source binary blob and has no documentation in the datasheet except from the binary blob. So it's only as one page which says, well, use the binary blob library for that, and that's it. So in order to get the Flash working also, I had to reverse engineer the bootloader. So a friend of mine dumped the bootloader, and I reversed in the Flash part with Ghidra, and from the Ghidra I wrote the Flash driver in Forth, and that was my proof of concept, and it worked. And then I also wrote with my friend, we wrote a C board support package. This is open source and it's also available on GitHub. So you can also program the Flash in C. We have a little bit board support package, and my friend, he made a development board which is also commercially available on, what's it called, not Mauser, the other one.
DigiKey?
DigiKey, yeah, right. It's available on DigiKey. So Benjamin Vernon sells it on DigiKey. Very high quality board. And yeah, we also reverse engineered the tool to flash the chip. So if you want to program it, you actually would have to use a very GUI Windows application, which I don't like because I use Linux mostly, and I don't like Windows very much, and I avoid it as much as I can. And yeah, we reversed in the bootloader, and I figured out how to enable the debug mode and also how to flash the microcontroller with an open source tool, which we also put on GitHub. So now you can do most of the development on this microcontroller with open source tools in C, and now also in Forth. Yeah, and that would conclude my presentation. Thank you very much. If you have questions, now is a good time.
Thank you very much. Are there any questions? Doesn't seem to be the case.
One quick question. What's the quality? Sure. How have you found the quality of the documentation?
Yeah, the data sheet is kind of okay-ish. It's not super, it's not as good as the STM32, of course. But yeah, it's usually quite okay, as you can see here, except for the USB 3, which is pretty much non-existent. So if we go here, this is all the documentation on USB 3. That's it.
Yeah.
Not more. Yeah. So no registers, nothing. So you have to reverse engineer their binary blob to kind of figure out what they do, but since USB controllers are quite complex, this might be a real pain in the back. And so, yeah, Benjamin, he was working on that. Actually, he wants to write an open source version of the USB 3 interrupt handler in C, yeah, for his board support package. So, yeah, that's in work. So, but there's on Forth, I don't have USB 3 support, and USB 2 also not yet. So you can do only regular microcontroller stuff, and you can, of course, you can flash the microcontroller over USB 2, yeah, which is the same port. Yeah.
Can I just ask a quick question? It's got 4 UARTs. Are you using one of those for the 4th terminal that we saw?
Yeah, I use the main UART for the terminal, the UART 1.
The reason I ask, I have an application for a sort of test tool that I have a need for 4 UARTs at a time. So would it be possible to use the board's USB port and squirt a terminal through that?
Yeah, of course.
Okay,
so the USB 2 high-speed should work. Yeah, shouldn't be too hard. So big, even if you have a ACM terminal, I think there's the ACM uses interrupt endpoints or bulk. I forgot. If it's bulk, then it's quite easy because there's example code already there.
Okay.
In C.
In C, of course.
Okay. Fantastic. Fantastic.
Yeah, excellent. Thanks very much.
Okay, so code is on GitHub, and yeah, and I posted on Facebook.
Thank you, Hans, for your presentation. Really interesting. And our next participant is our dear Ulrich Hoffmann. He will show us Grow Your Programs demo time.
So let's see. Yeah. So let's see. I share Genie. So I want to talk about how to stepwise define your programs. So let them grow from an empty screen to an application. And there are typically different ways to do it. And normally you have some building blocks, and you take the building blocks, words in the forth system, and combine them to get more sophisticated words, and then eventually you will have your application. There's another strategy, and I will talk about that strategy today, that is top-down development, where you say, I have the top-level forth words or the top-level functionality first, and then I break it down into smaller pieces until all the pieces are defined, and then my application is ready. And again, as many times, the truth is somewhere in the middle. So typically you would do both bottom-up development using some useful building blocks and building more useful blocks, and then also go top down and decompose your problem to actually meet in the middle. So that's a mixture, the approach meet in the middle. But today I would like to especially focus on the top-down approach. So we can look at it in a pure fashion, knowing that in reality you would do meet in the middle approach. So my setup here is an editor window at the top, and a forth system below. This is currently just a Unix terminal, but here we go, a GForce system. And I can just do appropriate definitions down here and go. And I enhanced GForce just a little bit. So there is actually a word called OK, and that's my turnaround. So whenever I think my program is now appropriate, I'm typing OK below, and then it will load and run the program and allow me to interactively test it whenever I want. So at the top, I have my program. So I do definitions right here. And then in the lower part, I tell the force system, the computer, what I actually want to do. So I would like to program today the game of rock, paper, scissors. I don't know, you probably know this from your childhood. So it's a game of two persons, and they shake their hands, and then they either say paper, rock, or scissors. And the other one does this as well, with the rule that scissors will cut paper and will win. Rock will damage the scissors, and the other one, rock and paper will wrap around rock, which means you have a circular dependency depending on the item that your opponent chooses. You can either win or lose. So normally, if you look at 1980s basic listings, there you would find similar games. Then this will have a loop. So you say run, and then it asks, what item do you choose? And then you say, well, I want to use scissors. And now the computer can be your opponent. It chooses a random item, paper, rock, scissors, and then do the appropriate assessment, and gives you some information what is supposed to what the outcome of the game actually, of that round actually. And so I have some background noise. Someone still has his mic on. Please close the mic, Hans. I think it's you. Please close the mic so that we can have a good sound over there. So I'm doing this for myself. Right. So rock, paper, scissors. And we want to have a computer player and a person player. And in forth, we don't have that loop that we normally have in a traditional, in a C program, where the main program is a loop. Think of Arduino, where you have setup and loop. In forth, you can also have the outer interpreter as your user interface. And so the idea here is, if I want to start a new game, I should say restart. And if I want to play rock, then I just type in the word rock, and so on. And this in this lower part of my editor window, I tell the computer what I want my game to be. So I want to restart, then it shouldn't output anything, and the stack effect should be as is. So that's what I want. And if I play rock, then the computer should answer, oh, you played rock. I play paper maybe, and I win because paper wraps rock. And so the score is 0 for the human player, 1 for the computer, and so on. If I issue paper, then it should display something else. Of course, I want the move of the computer to be some random move. So that's the idea. So how do I develop this kind of program now? I'm typing OK here, and then it loads my program, and it says, well, I don't know actually what restarts means. So I define what restarts means. In this case, I just say, for now, it's just restart does actually nothing. So finish this. So fine, I go and say, OK. Then it says, well, I don't know what rock means. Well, maybe I define rock as a word that doesn't take anything from the stack and doesn't leave this because it just outputs text. And I want to play the rock gesture. So I will do a rock turn. And then the computer will answer with appropriate things and so on. Let's see. Fine. Oh, it doesn't know what underscore rock means. That's the rock item. I have rock, paper, scissors, so I won't actually have an enumeration. I do I've talked about enumerations last time. So I want to do enum rock, enum paper, enum scissors, and this leaves me the number of items on the stack. So I maybe do something like constant number of items. And then, well, I can actually also say something about what is supposed to happen with this. Okay, it says, well, I don't know what enum is. Yeah, of course, that's not a standard word, but you can define enum as you want. Enum takes n and returns n+1, and does, as we could have seen in my last talk, constant, or maybe content is also nice. I just keep that. I do some errors here, and I say, okay, well, oh, it says content, I don't know, but constant, you know. Okay, great. It doesn't know what turn is. But before we do turn, we can also do some properties here. We can say what we want to know is rock is of course equal to rock. That would be no surprise. But also we want to state that the other items are different. You get the idea, like paper and scissors equal is false. So something like this. And you see, it still says, well, turn is not okay. And that is actually the turn that, that's the turn that we have here. So maybe I need to move this up a little bit to see that I can get scissors, see, scissors. And we are back to turn is not equal. So you get the idea. I can put in some properties, some concerns that I have down here so that it will actually test these and give me some information. Well, we want to know what is a turn actually. So we define what a turn is. It takes the item from the stack like rock. And then it should remove it from the stack. And what I really want is, turn, do turn with human moving item. Yeah. And what do we want to do? First, we want to know what the computer does. So we let the computer do its counter move, and then we display whatever is happening in that turn. So we know what the human plays, we know what the computer plays, we display what's going on, and then we actually want to rate it in some way and give out the score. Maybe we call this .total. And then output a space at the end, something like this. So a turn in this rock, paper, scissors game is I give my item rock, paper, scissors. The computer does its move. We output some statistics, and then we do some calculations, find out who is the winner, and so on, and give out the appropriate result of this turn. So let's see, that's fine. Let's go. We don't know what counter move is. So then, well, I just move this down here. And let's see, we define counter move. And you see, I'm defining the words above the one that uses them, as this is the normal way to do it in forth. You first define words, and then you actually can use them. But in the way we're currently defining it, I use words that are not defined yet. So I later on define them when the compiler tells me so that something is undefined, tells me so that I know what, I define them up front so that they can be used in the later words. So let's see, what will the counter move be? Well, we know the number of items. It's 3 actually. Is it 3? Number items is 1. What did I do wrong? Okay, that's interesting. Dop constant 1 plus. Number items supposed to be, is supposed to be 3. Number of items. Yeah. So 1 says it's actually 1 item on the stack, and 3 is the correct number. So number of items is 3. That is great. And I want to use a random number that I want to use. So I say random number items, and then I can use choose, which gives me a number with the upper limit of items, 0, 1, and so on. So 3 choose would give me 0, 1, or 2, which happens to be the values of rock, paper, and scissors. So that's actually a nice thing. And while it doesn't know what choose is, yeah, maybe I have to use a random number generator. And maybe if you know GForce, then you know it comes with a supplied random number generator. And you can just include that file. And so now what does it do? It still says, I don't know what choose is. And so let's have a look at what random does. So this is the GForce random number, and let's see what the interface is. It has R&D's seed store, and it has random as its as its last user word. So you give it a number, and then it turns. So right. So we have actually 2 possibilities. We either could stick with our word choose or use random there. And because starting forth actually calls this word choose, I would say I do it like this and just rename random to be what I want. And so dot turn, it doesn't know what dot turn is. So let me see. Dot turn should display the current turn. So it should display the person's move, the human's move, and it should also display the computer move. So dot turn has 2 items on the stack, item 1 and item 2. Item 1 being the one of the human, item 2 being the one of the computer. And let's see what we want to do. We want to display something like you play over, and then we want to display the item, dot item. And if it's a tie, then we want to display I play. Let me see, over dot item, maybe something cosmetic there. Display also some period, and I play dup.item. So first line displays item 1, second line displays item 2. And then we do some assessment of what's going on. Maybe if it's a tie, then we remove the 2 items and we just display, well, that's tie. And maybe like this, and we're done. Exit then. And then let me see if item 1 wins over item 2, then we would say, and I lose. And if I don't, if item, the human, does not win over the computer, then the computer will win and I win. So something like this. Right, great. So let's another step forward. Oh, it doesn't know what item is. display an item. We have the enum, so yeah, let's define what an item is. We can define what an item is, maybe also here a appropriate stack comment. It could be rock, paper, or scissors. So I say if it's rock, then let's display rock. Rock. If it's, we don't need to do that. If it's paper, then, well, let's display paper. And otherwise, we suppose it's scissors, and we just display that. Right. So let's see if we can test item appropriately. So we do it here and say what we really want if we output do paper dot item, then it should display paper like this. And if we say rock dot item, the word should output rock. And if we scissors item, it should output scissors. I'm doing it wrong here, or maybe I'm doing it right in the test and I do my program wrong. And so let's see what's happening. It says, well, why does it say out? It says invalid memory address. And what's happening here? So I can interactively check here, paper.item. It says invalid memory address. So now that's interesting. So what's wrong here? Dot item. So I'm convinced in principle everything is fine. No, it says invalid memory address. Paper underscore rock equals no. And then it compares this. This drop is wrong. Yeah, because if I don't duplicate, I don't need to drop later on. So to make it more clear, I could do a dup here, and maybe that's a better approach to have it regular, but we dup something and we drop it here, and we need to drop it here as well. But that's probably fine. So let's see. It says paper. It says undefined. It's not, it's the arrow that we want to have in our test. So let's see. And here it says something. Unexpected output. It outputs scissors. Yeah, and it actually outputs scissors, and it should output scissors. So let's fix that. We do it like this, and then we run again, and then it just says, well, I don't know what tie actually means. So we could in principle output a turn, but we have to define what tie actually means. When do we have a tie? If if both do the same, two papers, two rocks, two scissors, that's actually a tie. So we can define tie, item 1, item 2. And this gives us a flag, and it's essentially just equals. So great. Let's see. We need to define what win actually does. So probably to define what win does, it's best to have a table where we have rows, paper, scissors, rock, and columns, paper, scissors, rock, and then we have the entry that is actually the winner of what's going on. So let's see. We define win as item 1, item 2. And the idea is to look into a table and see what's right. So I have a look in the table where I can find the winner, and then see if the winner is equals to item 1, and then item 1 wins over item 2. Over item 2, something like this. Yeah, so winner will actually find out, having 2 items, which one is the winner. If it's a tie, then it will just give that one, and winner is not yet defined. So yeah, let's say we define winner, item 1, item 2. And this gives us item 3, the winner of them. So rock, paper, rock will be the winner. Yeah, and we do this with a table lookup. And first we look in the appropriate, multiply with the appropriate row line, add the other one, and then index into a scores array and fetch the winner from there. And so let's see. It doesn't know what scores is. Well, that's actually the table that defines what how this all looks like, how the rules go. Scissors, something like this. So let's see. We have rock, and with rock, of course, rock against rock. Whoops, is rock. Rock against paper is paper. Whoops. Rock against scissors is rock. And then we have paper. And paper against rock is paper. Paper against paper is paper. And paper against scissors is scissors. And then scissors. Scissors against rock is rock. Scissors against scissors is scissors. And scissors against paper is scissors. And scissors against scissors is scissors. So, right. Again, we might want to give some request to how winner should actually work. So we might say winner rock and paper, and the winner of these two is supposed to be paper, and scissors, rock, winner is supposed to be. These are actually the rules that I mentioned right up front when I explained the game. Rock, winner, and also here winner, scissors, and rock is rock. So let's see what's going on. It doesn't know what rate is. Well, that's great, because scores is fine, winner is fine, all the tests that ran here are fine. So it looks like winner actually picks the appropriate winner, with at least with the 3 conditions that I have written down. And the current error is in line 55, which says, well, let's rate what's going on. So in the end, what we want to do is something like display these scores here, and So we could add now variables that hold the points that the human got, or the points that the computer got, and display them. So, but maybe we just weaken our restriction here. So I'm afraid I ran out of time anyways already. And so let's see what we can do here. I just don't define what rate actually is and dot total, and we just leave it as is. Yeah, so we do the turn. It says, well, I'm choosing this, and then it displays the result. So let's have a look at this. And it says, well, I don't know what paper is, but everything else is right. Well, here it says something like unexpected output. You play rock, I play paper, and I win. And it displays wrong number of results. The actual output, you play rock, I play rock. Tie. Which is rock, rock. Yeah, well, because it's random, we don't know. So maybe we say something like initialize this appropriately. And let's see, what was this initialization that we could do? We could do store seed store, and we do that here, 0 seed store. And hopefully that will go away. No, it's not going away. So, but anyway, let's try and see. Well, this looks not so bad. You play rock, I play scissors, and I lose. And 2 elements on the stack. Well, that's because of my shortcut. I'm doing 2-dub here, and that's because I wanted to use that later on. So, okay, let's see, much better. Let's see, I can say rock. You play rock, I play scissors, and I lose. Well, that looks fine. But it still says paper is not defined. Yeah, well, paper and rock and scissors are very similar. So I say do a paper turn, and scissors is do a scissors turn. So and okay, well, unexpected output and unexpected result. It says scissors rock winner is 0, and 0 is actually rock. And well, that is fine. And so my constraint is wrong. Scissors and rock, the winner is rock, scissors, and what do I want to do here? Scissors and paper. Yeah, you see, also the test could be wrong. So paper, you play paper, I play scissors, and I win. You play paper, I play scissors, and I win. The crucial thing is this space here, because you really want to have the exact. You really want to have the exact output. And so let's do it. Fine. So actually, whenever I'm in doubt to do something, I can play rock, paper, scissors now. So I choose paper, and you play paper, I play rock, and I lose. So I'm win 1 against the computer. I'm playing scissors. You play scissors, I play scissors. Well, let's tie. Okay, then I play rock. You play rock, again tie. I play rock again. So, I lost. Yeah, I play rock, the computer plays paper, and I lose, so the computer wins. So that's rather nice, and you can extend it with output of the scores, of course, giving some statistics, who wins. And yeah, the nice thing is this program just grows. I just loaded it and I followed the error messages that the forth interpreter gave me. And I defined to make it a little bit more happy. And then it came up with other complaints. But in the end, everything is resolved. And I have my application. And I also have some tests in between, which I can now move downwards. Now that everything is defined, I can just move these things downwards in the test section. Something like here, for example. Yeah, and still it will just, okay, it will just go and be fine again. So I can separate the test from the definitions and have an application that runs appropriately. So I was surprised when I tried this with other application that it somehow naturally led me to the solution. And I was just not shy explaining something and defining something. And I don't know really how to do it, but I know parts of it. And so I just went and defined some stuff like, I know a turn it needs to have a counter move of the computer and then display some statistics. And just, I didn't know what counter move was at that place, but then the computer complains and I explain what counter move is. And I can focus on one thing, postpone the things that I didn't know yet and refine them later on. And eventually you come up with all the missing details, and then the application is more or less finished. And because it has the tests in between, then you also know that it actually works. And you saw that some tests failed, either because I mistyped the test or I did an error in the definition that I did, something where the computer says, well, this is suspicious, please go and fix it one or the other way. And this leads me to think about that certain aspect of the application and fix it appropriately. And yeah, so I think that's a rather nice way to grow your programs. Today, we've been looking at just a desktop program. So this is all GeForce running on my Mac. And but it could also be, the lower part could also be a terminal, and it could be in an embedded system. And then you would do the appropriate tests, and maybe you have to inspect also the outcome. If you're looking for some sensors, then you might need to cover that as well. Or if you actuate something, then you need to see what's going on. But the principle more or less stays the same. So you start growing your programs in this sense, top down, from the top level words down to the application. And as I said in the beginning, reality is more a meet in the middle approach, where you have building blocks and you build more appropriate things given the experience that you have, and then you grow downwards from the top to the application. And yeah, but I think that's it's really fun programming that way. And let the computer guide you through the programming. So
very nice, Ulrich.
That's what I wanted to say. Thank you very much, and maybe you have some questions for me.
Yeah, I've got a question. What does that curly bracket thing do? Is this kind of a unit test, or
Yes.
I'm not familiar with that?
Yes, exactly.
From GeForce?
Yeah, well, it goes back to a test program that John Hayes did for testing standard compliance. And there's actually a t-tester in GeForce, and many other forth systems have similar things. And what you do is it defines T curly brace and curly brace T and many others in GeForce style. And then there's also the file tester.fs, also in GeForce, and it just says, well, use the old notation, curly brace and open and close to do the appropriate test, and that's what I'm using here. And then this output is an extension where you normally you just say, okay, let's see, 3, 4 plus equals 8. Yeah, and then you do that, and it says no, it's not 8. It's yeah, it actually calculates 7. And if you say, well, 3 plus 4, then that's fine. And my extension actually says, if you say 3, 4 plus dot, then yeah, you normally get the output, but yeah, it will just run, but it doesn't check the output. And so you could say 7. Yeah, and then if you do it, then it says no, no, no. You say it should output 7, but it actually displays 7 space. Yeah, which dot actually does. So if I just say output 7, then it still says no, 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 7 space. That's the actual output of dot. Yeah, and if you do that, that's fine. And this does some GeForce magic, executing a word, capturing all the output into string variables, and later compare them, and so on. But yeah, so the idea is you specify what you want to have with these tests, and yeah, it's a unit test framework for forth. And then once everything is defined, you also check whether it does what you want.
Thanks.
Other questions? Okay, that's not the case. So I encourage you, try this out. Moving away from your normal style to get some experience with it. I don't say it's the stone of the philosophers, but it's nice to have it in your pocket. And so once you're stuck and say, well, I don't know how to go, then let the computer guide you to the solution. Right. So thanks again. And so let's have a look at our schedule. Next speaker is Pablo Reda, and he will talk about R3-forth and how he does TV broadcasting with it.
I share my screen.
Right.
You look?
Yeah.
Well, I do a system for TV broadcasting in a local TV station. All is made in forth-kernels. This is the system running. This clock show a module defined in a grid of programming. I have a description of the day with or and what module play in this time. The idea is the system emit images, video, get some news from web, and something like that. For example, this is the number of the day. This is the or when the modulars then emit, and this is what do in this time. For example, this is a clock in 4 seconds, and add the weather. And when I start the program, first for 4 seconds show this clock, and then the weather for 16 seconds, and repeat again. This is the project. This is all the source code. They are three systems in this program. One emit the programmation, parsing the grid, and loading, and every module. And for example, this is the clock, and the clock is made in here. Here is the code. Every mode have an initialization module or initialization word, and running mode word, and finalization word. For example, for load images and then removed from memory. In this case, this word draw the clock, and initialization only set the final time for this module, and the run word only show the clock and execute the timeline. The timeline is a library made in Forth, of course, who admit timestamp and do things like show image, move a graphic or something. I have model, for example, for show videos. For example, here, back to 1 second to clock and show a video. If I start the system, show 1 second the clock and show a video. And I can add a title. Oh. Okay. A title and a description below. Then these messages are configurable, programmable. Another interesting part of the system, perhaps, is the video player. The video player is working here, and the shape is the same. One word for initialization, one word for running, one word for finalization. Here I, in the initialization, load the video. And make a frame for draw every frame, and put this in the timeline, and in the running, put this frame buffer in the screen and wait for the end of video. And all these work are working, calling the FFmpeg, the library for play with videos. And for example, another module is for C product of the commercial web of the my town. Then one part of the system play this video in a computer in the TV station. Another part of the program get of the web news and commercial things for make programmation, and the other is a web configuration for this program. Here I am touch by hand the programmation, but in the real system I do a web program, but not in form, for configure this system. And well, this is something how work this program. Any question? Hello?
We can hear you okay.
Okay.
How do you change the program? The schedule.
What?
How do you change the schedule?
Oh, okay. I can show you is I start a web server. Now this, and take local host. Oh, wait. Here. This is the grid of programs. I can load avisos are Peter help me. avisos.
Publicity.
Yes, yes, publicity, communications,
Commercials.
for,
Commercials.
yes, there for in this channel, the date of the tones are announced by TV, and here I can make, for example, image for
basically
public.
I can help you, Pablo. Who asked
Yes.
how to change that? I don't know who was making the question.
It was me, Francois.
Ah, Francois. Then Pablo is changing everything over the web. He told us in the beginning he can make this on a browser.
The configuration is made in a web browser.
Yes,
The machine.
that's the answer. That's the answer, Pablo. No need to show every step.
Ah, okay.
Over a web browser.
This web modify the text file for who describe the programmation of the channel.
I love this work from Pablo because I showed this to Chuck the other day on the meeting with Chuck, because I think it's amazing that we have somebody in the group that makes an application that is on television. It's running on television first.
Nice.
So I am impressed, really impressed.
The second part get from web for any page and scan the page and get, for example, the weather of the town or news for a local web page for news and showing TV.
This is automatic, Pablo, or you have to type it, to type the information.
No. It's automatic. It's automatic.
Wow.
This
amazing. Amazing.
For not working, for game morning without working.
I must sincerely, I must laugh. I will laugh half an hour now on the grass, because there are so many people that say they can't program in forth, and I see all this work, so I must laugh. You can do whatever you want. Forth is a programming language, and people make so much trouble and so much questions. I can't understand. I don't understand.
Of course. And I have a advantage for use forth. Is more easy to change.
70 case. 70 he does all this in 70 case.
Yes, this is the source code. The most expensive module is 11K, and it's because have a lot of animation. I have a lot of animation in this page, and need to describe the transformation, the text and this.
Yeah, nice. So, are there any questions to Pablo? So, what kind of computer does this run on? It's the television computer or some detached system?
A common PC with Windows 7 in 4 gigabytes. I think i5. Intel i5.
Yeah, but it's a distinct system. That's not the one that runs the TV shows, or that's you prepare the images and then you transfer them to the display computer or of the TV station.
Yes. With the web interface, I upload MP4 AV imagen and adjust the programmation, and the system emit all the day. The local TV station have very few live programming, only 4 hours of day, and the rest the system is emitting this programmation.
I apologize. I have a newbie question. I was curious, in your code, the vertical bar character, is that a comment character in your?
Yes.
Oh, okay.
Yes. I need to explain something else. Sorry, Pablo, I interrupted you. If you want to go ahead. I wanted only to say that Pablo makes this in his own R3 force, but you can do the same on GeForce and on every other force. You can do that. There is no problem to do such an application.
Sure.
But we see the difficulties for beginners. Because, and Ulrich did today a wonderful example. This will be stored in our YouTube channel, and we need more of this kind of activities, not from Ulrich, but from other people like Cecil Bayona, for example. He's a super forth programmer, or from Christian Hinze, that every time tells me he's a beginner, but he can do the same as Ulrich did today. Write a small application, type it on the screen, or prepare a print screens and show the word. We can program with forth like in any other language, because this is very important for people who begin with forth. They don't know what forth is and how they can begin.
I see in the embedded programmation the less memory used by forth is very advantage, but in the desktop application the speed and the memory are for forth are infinite, but the real gain in forth is the flexibility of forth in change your program. I think this is very easy change of opinion when you programming and change the code. In other language, you prefer patch the code and not redoing. Here is redoing is very no cost so much. I think this is the key. I promise prepare a chat with this opinion, with my opinion about this, and and practice more English too.
Excellent. I love that. Ulrich, you are muted.
Right. Yeah, impressive. That's what I wanted to say. Thank you very much, Pablo. And yeah, our next speaker will be Peter Forth, and the day ESP3840 Forth spoke. Wow, what's that? Peter, please explain.
Thank you, Ulrich. Let's share my screen and see where we are. I am without my mouse, and this is a touch thing here on my on the, because I have so many things plugged in my notebook that I need to make this presentation without mouse, and so I am a bit confused. You will find these files on our GitHub of the group. This GitHub, I invited Ulrich. You need to accept my invitation, Ulrich, if you like, and give us advice. As also, I invited also Brad Nelson, who is here with us. I need to invite Brad Rodriguez also. So we are everyone who wants to participate in the ESP32 Forth repository of the group, and every member has a folder. So we have here Pablo Reda, and we have Alexandre, and Howard Oakford, and Jan, and Willem, and all the members here from Francois, all the members from the forth-2020 who want to program with ESP32 Forth. For example, Harald has added his repository in the last days, and Bob is very active. Bob Edwards is very active in his repository, and you see everyone has here his folder. So if you go to my folder here from Peter, you will find this example. It's the speaking example, and you can download and test. It's very easy. You see the Arduino screen, how to install the library. This is based on a library called Toki, and this Toki I found I had already installed in my Arduino Uno as a speaking multimeter. It was very nice, and I decided to translate using these user words that Brad implemented a couple of months ago, and you see how to I added every words inside the Toki examples. So basically, you follow these instructions, and you will listen to ESP Forth talking. I did a video also. You can watch this video on your computer, and I found this grok from the day of the day the Earth stopped. I found an inspiration because the voice you will hear is like a robot. It's the Toki speaks like a robot, and so I found this old grok very inspiring. And of course, you can go to the projects here on the ESP32 site of the group, which keeps growing and growing with a lot of people participating, and find all the links. So this is easier to find everything what you need. And let me show you one of my applications. Okay, here hardware. Hardware is super easy. You just use one pin, the D25, and a ground. You need ground and one pin, and you can plug directly an earphone, a small speaker, or a speaker with an amplifier. That's up to you. Of course, an amplifier is the best option, but a small speaker works well. And if you have an embedded device and you want to have a warning system, for example, in the robot of Atle, in the smart car, with a small speaker will be enough. So it's very, very easy to set up. So here you see I installed the words inside ESP32 forth, and I can show you how this thing works. Let me take some of these words. Sorry. For example, here I copy.
Increasing to in low thunderstorms, overcast, unlimited, low rain, ice, heat, fog, heavy land, thin on, variable, obscured, aloft, ceiling partially, visibility, drizzle, indicated, severe, moderate, probe, ready, set, speed, under, operator, amps, mega.
Well, and now what the interesting
firepower complete repair.
Yes, then he needs to stop. I don't have a stop button implemented, but the interesting thing here is, since we have an interactive system in forth, we can create our own words. For example, HG. Let's define these words. Copy. And you see, for example, I can program a pin of the ESP32 forth to fire the message H2.
Range safe.
So the range is safe, and I can fire the message H4.
Danger, danger, unit, Alpha, Bravo, Lima, Charlie, Probe, please, probe.
And this is interesting. This is an interesting application for the guys who make, who are radio operators, because you can pass a lot of information automatically from a system very far away from you, and you receive speaking information. You don't need to have a complex device, but just hear what the computer is telling you as information. So this has a real important application. This is not just for fun. And I developed also for today a small again using ESP32 forth and the libraries we have of the TFT screen. I developed a calculator that speaks the numbers. So I will show you. Let me open more the screen. My setup is complicated. Here is the ESP32, and with only 2 cables, this one, the red one, and the white, which is ground, you go to the speakers here. These are my speakers. And I will show you the calculator. So this is speak calc. For example,
6, 3, 2, 5, 9, 8, 4, 1, 0, 7, 8, 8, 9, 0, 2, 2, 5, 6.
So you see
0.
How you can use Toki, this interesting library, together with forth, and all is working with forth from ESP32 forth. Again, we are. And if somebody has a question, I am happy to answer. The speech module that you use here, what type of device is it? It's a standalone device, or how is it? I cannot hear you, Brad.
Is that better?
Yes, yes.
Yeah. Is the speech device that you used, is it what's the actual hardware? Is there like a synthesizer chip, or what is the?
Nothing. It's the library.
Oh, it's just a library. Ah, very cool.
You can test it right now. It's just you take the user words from here. I have the larger version, and put these user words in your ESP32 forth.
Very cool.
And how you install? You need to install here on Speaks. The only thing you need to install is this library, Toki. It was funny because I was working with this with my mouth shut. I did not talk to anybody, but I don't know if I said this to Brad or to some of our friends in the group. And the same day I was preparing this to show on Monday in the group, and Brad was doing a demonstration on Saturday on the SVFIC. And we were talking on Sunday with Pablo, and Pablo told me, but did you see, what are you working on, Peter? I said, oh, I am working in a speaking application for ESP32 forth. And did you see the video from Brad? No, I didn't see that. Oh, I went to SVFIC channel, and Brad was doing the same, and it was very, very funny, very, very nice.
Yes, but yours is more impressive because it's on ESP32. Mine was just on Linux calling out to eSpeak. So, yeah.
And I need to say that I will not say like Christian that I am beginner, because I work with forth for so many years. But this is for beginners. This is so easy to install and to use and have fun. Just install and a speaker, and you will see.
You know, we have weather stations in our area, and the voice from the weather station is identical for your application. So they must be using something similar, you know, based on the library or something, because it's identical to the weather, you know, partly cloudy with low ceiling of 2,000 feet and so on. And they tell you the weather, and there's a whole slew of them. So that because we're a mountainous area, so depending where you are, you listen to different ones, and they're all exactly the same.
Cecil, is this an automatic station?
Yeah. 24 hours a day, giving the weather forecast It's kind of handy.
Yes.
Yeah.
Sure. But
So they must have something similar. Not forth probably, but wouldn't be surprised if it's an Arduino or something like that on using that kind of stuff.
Even if you don't have an application that requires voice output, it's still a great debug tool, because you could just speak in a state of your application while developing. It turned out that is very helpful. I mean, you can light an LED in different colors, but you could also just speak. And this has the nice property that you don't need to look at some place, but you can just hear it while doing other stuff. So that's really nice.
And in the moment, I am, like I said, I am using this Toki library written in C, but I intend in the future to pass as much as I can to forth, because I learned how this coding works. It's based on the LPC. It's the linear prediction coding. And I think we can pass these algorithms to forth, because it's not so difficult and it will take much less memory. And it's not necessary, but if I have enough time, I will try the challenge.
And the voice you say is robotic, yeah, but it actually sounds very good. Clear, enunciates well. So it could be used in a lot of things.
I'll have to take a look at that library to see if you can make it a spooky voice just in time for Halloween.
John, another thing interesting. You can add your own voice. I will show you. You can add your own speech on this using Audacity. You can record your voice, add new words, of course, and then you save. And Jan did a conversion program. We have here a conversion program. Let me see. We will show more of this during the week, because Jan did a conversion program. There is this is not so complicated. This is I wanted to show you here. This is the vocabulary, for example, of the Texas Instrument 994A. And you see, for example, A, the word A. This is the code.
Oh, very cool, Peter. This is using the TI 994A's speech.
In one of the
software emulation.
Software emulation. Oh, very neat. Yeah. My very first computer. So.
Yes, there are many libraries here, Brad. You can see them on the GitHub. And my intention is to add these bytes, these arrays of bytes from forth interactively, because in the moment, this is fixed as program memory, as a constant. But it would be interesting to add this as forth memory. And well, we are working with this very recently, and there is a lot of things that we can in the community improve.
Yeah, very nice. Are there any questions to Peter?
Yes, I think Christian will have one.
Sure.
Peter, the chip that you're using for the audio amplifier, is it using an I2S interface? I'm not too sure I'll hear your answer.
Interface, I did not hear you right well. Can you?
Yeah, I'm not hearing Peter's voice very loudly at all. Can't hear you, Peter.
And now it's better.
Better.
Oh, you're back.
Okay. Okay. This is the problem with so much stuff here for demonstration. So, Christian, I am just using amplifiers of these speaker boxes.
Okay.
From computer speaker boxes, but you can use only on pin 25 of the ESP32. You can use a headphone or any small speaker.
So it could you don't have to use the small module that you showed.
No, it's an option. It's an option.
And does it? From what I heard, it's basically just an MP3 or a wave player.
It's a wave player, exactly.
Okay. So it could speak any language.
Any language. You can also music. You can record anything on with this Audacity software. You can record your own voice, or you can take music from the radio and pass. I have some examples. Hasta la vista, baby, from Terminator, and I have many of these wave files on here on forth.
I used Audacity before to convert most of my LPs.
One more here. Let me show you. Hasta la vista here. A small step from Armstrong on the moon. Small step here. It's all recorded. You can record your own.
Mm-hmm. Nice.
But, okay, it's something that you can use for a game, for example, for playing chess or to pass information. I was using this years ago as a multimeter, speaking multimeter with an Arduino Uno.
Mm-hmm.
Mm-hmm. Maybe one more question.
Sure.
I saw somewhere TI-99. Is it emulating what a chip that is in there, or what?
No, only the words of the TI-99. It has the same words.
Okay.
But no hardware, nothing of hardware. It's all in this arrays of wave files. I need Ulrich. I need to present the group a new member, Christian Larsen. Where are you in the world?
Hello, Christian.
So I'm over in Washington State on the west coast of the United States.
You are a programmer.
I am. I did mostly programming in C, C++, Python, a little bit of Lua, and Fortran. I did an internship a while back where I was helping update Fortran codes. I didn't like writing in Fortran, but I just learned about Forth recently and was wanting to learn more. I'm pretty excited to hear about it. I'm looking at the Wikipedia page about it right now, and it seems like it's, I mean, I'm pretty interested. It looks pretty cool, pretty simple. Yeah, I'm excited to learn about it.
Welcome, welcome.
Right. Yeah. Very interesting. So, shall we proceed?
Yes, yes, go ahead.
Right. Our next speaker is Brett Nelson, and he will give us an update of what's going on with ESP32 forth. So, not can it only speak, but it can do much more. So, Brett, please.
Indeed. Let me go ahead and do that. Yeah, so this'll just be an update of things in flight and or things that have happened in the last 2 months or so since I last spoke to this group. There's a sort of an arbitrary laundry list of stuff that's been added. There's case statements that got added finally. There's been some improvements for the Bluetooth serial terminal, and there's some words that will help folks manipulate the storage in the device a little bit more easily without somersaults. And then there's some progress towards code words and dump, and some improvements with the camera, and one additional hook I added last night, actually for the user words feature that Peter uses. So, so let's talk about case statements. So, forth case statement was something that's not all forths have this one, but it seems to be pretty widely used, and I actually sort of felt the absence of it in ESP32 forth because of a coding challenge that Bill Ragsdale did at the last SVFig meeting, and it was a conversion from numbers to sort of spelled out numbers, and it was possible certainly to do without case statements, but case statements end up making it a little bit more terse. So I've added this to the set of built-ins in the bleeding edge version of ESP32 forth. When you have something like this piece of code, it will underneath sort of at compile time get transformed into an if tree, and we'll sort of splay things out. Nothing particularly deep. I mean, it's been implemented all in high level forth. The main advantage of the syntax is that it's terser when you're branching on a value.
Presentation on
It got me thinking a little bit about how case statements work in forth, and sort of thinking about how that relates to other languages. In C in particular, case statements are kind of, switch statements are, one of the sort of underlying goals is that it can automate the creation of a jump table, whereas in forth they're more of a, the syntax sort of prescribes that they end up being more of an if-else. But it's so close. It's actually, maybe with some careful choices about transitions from compile to interpret time, it's got me wondering whether a small variation on the ansforth case statement would allow for the construction of a proper jump table, where the C compiler will, on a switch statement, if there's dense sections to the values that you list, it will arrange things so that it will do a mask operation or a branch around it, and then look up each possible path in a table, which can be more efficient. So maybe worth exploring, although typically in forth when you do a jump table, you just do it explicitly with create and tick and so on. So not particularly forthy, but got me thinking about whether or not the ansforth words are sort of had that as a design goal or not, which I imagine there might be folks out there that would know what the history is and the choices for those words. Another one I'll flag. I don't think I'm going to demo it just because too many things to talk about, but For those that use the Bluetooth serial terminal, I noticed that that it wasn't working on a regular ESP32 port. I tend to use it for my own purposes primarily with ESP32 CAM, and that one has a little bit more memory, and so it ends up being something where it sort of worked fine with the thresholds that I'd set. I discovered that the Bluetooth stack needs quite a bit of runtime memory. It needs 128 kilobytes of free heap space. And so that was more than I was leaving available to the system outside of the fourth heap on a regular ESP32. So I've added a word called relinquish that releases the back end of the chunk of memory that gets allocated for the fourth heap back to the system, and that allows the B term entry point to release at least enough memory to for the system to run. So I'm able to call one of the internal words that lets you figure out how much memory is free to the system and see how much I would have to release in order to give up that 128 kilobytes that Bluetooth needs. The Bluetooth stack in general is a pretty sort of inefficient one on the system. It really grabs a lot of resources, so in any event, if folks are interested in trying that and have hit troubles in the past, give it another go. In principle, it's very straightforward. You just do you have to build and do B term, and then you're able to connect to it as a Bluetooth device. This one I maybe will go pop out of the slides and give a demo. So I added some shell words. I found that you've got some local storage on the ESP32 on the SPF on the SPI FFS file system. And I found myself sort of feeling like, well, it's weird that I got this interactive thing, but I have to do quite a lot to see the contents of what's there. And I also for ESP32 CAM, it has a built-in SD card slot, and so that one you can also mount it and interact with the storage and the same thing. And so I've added some words that mimic Bash a little bit, just sort of the basics. And the only issue is that ESP32's built-in libraries, by default, they don't handle subdirectories. And so for the SPI FFS file system, they'll treat it a path name with slashes in it as if it's that's part of the file name. So there's a few words that I related to moving around in directories and so on that don't work the same on Linux versus ESP32. I haven't gotten around to adding it for Windows. There's actually some quirks in terms of how that would have to function, but I'll demo this. So I've added so there's for those that know, bash prompt, there's copy, there's move, there's remove. There's touch, which will create a file, an empty file, and then cat that will print out the contents of a file to the terminal. And most critically, there's ls to list the files in a given path, which is handy. On Linux, there's also directory-related words like cd and make dir and remove directory. I am a little bit tempted to explore emulation of some idea of a current working directory on the ESP32, but I'm also mindful that that's going to just sort of add more junk to the baseline footprint. So I'm also kind of not sure if that's a good use of space, given that there isn't real directory support there. Interestingly, I was looking at the insides of some of the file system libraries, which come from the underlying ESP IDF system, and there is an option in there to enable directory support, but for whatever reason, on Arduino, I guess they have that turned off by default. So a bit of a mystery. So let's see. Let's pop out and do a demo. Let me actually, I will connect to an ESP. Let's see. I'm going to load put this on there. Is that readable to folks? No, too small.
Too small.
Let's see. Let me change the way I'm sharing my screen. How's that?
Yeah, that's great.
That's good. Okay. So so the way these words work is that you can do ls, and right now there's only the blocks file there. I'll demo a thing that got added. I demoed this last time when it was in a little bit. It's not in that less of a rough state, but there's a visual editor now, so you can create a file. Let's say I call it hello.txt, and hello there. This is a test, and I can hit Control X and save the file. And now if I do, actually I'll just list the directory. Now I see that file. I can now cat out that file. Oopsie, I have to do the full path because it's there. I can copy that file. I can now do ls, and the file is there, and I can cat it out, and it's got the same contents. If I decided I wanted to rename it instead, I can and it renames. I can just create empty arbitrary files, and those will show up. And if I want to clean up, I can just do that, and so on. The visual editor, I've added some instructions on how to use it to the website, and so if the keystrokes are pretty simple, it's just arrow keys to move around. There's, I think, page up and page down. You're always in sort of an insert mode. There's this little weirdness about the two cursors, which I'll get sorted eventually, but for now I went with what was easy to implement, and then the main keystrokes you need to know are Control S will save, and Control X will exit, but it will also ask you if you want to save each time. And so I can save, and let's see. It looks like there's question. Is there a question in the chat? Let's see. Nope. Other stuff going on. So that's that. Let me switch back to the bigger screen. So code words. This one actually I had put it on the back burner for a while, just of the stuff going on, and it's actually got a lot of complex kind of wrinkles to it. So I've added code words. There's but the assembler is not yet ready and working. I use a C call signature to get a stable binary interface for code words. I'll describe what I mean by that in a second. And then one key issue is that on the ESP32, there's a distinction between data and code memory. And so you have to actually, I don't directly use a piece of memory in the fourth heap. I have to allocate a separate block of memory for code words. And I've also added support for a version of this on Linux. There's actually similar in Linux. The issue is that you need to have the protection bits for the memory. You can use arbitrary memory for code words, but you would have to specify to the system that they're code, because otherwise it will be angry when you try to execute them. I will hopefully have an assembler of some flavor, at least for ESP32, coming soon. I had started it on it previously before I had the code word support, which is really the wrong order. It's good to be able to interactively test that you can that a piece of code works and to know the calling conventions of the system before you start working on an assembler, as it turns out. In general, this is lazily loaded by the ASM word, so you're typically, other than some memory in the system, you're not paying for this in terms of RAM unless you happen to execute ASM. There's code to define a word and code that ends the word. Because the code memory has to be separate, there's a C here word and a C a lot word, and then some words to compile code into the dictionary. The calling convention, the way it works is that there's a new opcode that transitions into a code word that's in the data the parameter area of the current word, and it calls into it using a C call, so that there's a fixed set of registers involved based on the ABI of the particular platform. So I believe I cribbed this, I think, from, I don't know if it's from G-Forth or there's some proposal for a different way to have a boundary in the edge of G-Forth where you pass in the stack as a parameter, the stack pointer, and then return it. And then for floating stack, which you often don't care about in most words, you pass in a pointer to the floating stack pointer, and that way there's the option of using the floating stack, but you're not sort of obliged to deal with it typically. And so on x64, this means that you get the data stack in on DI, but you have to make sure that it comes out in RAX at the end. And then the floating stack, you have an indirect hop to it on RSI. On ESP32, it's the extensa instruction set, although actually I should caveat here, this is, in theory it all works for the C3 and the RISC-V stuff, but I haven't wrapped my head around RISC-V assembly yet enough to have really vetted that anything substantive works there. So you get A2, actually, sorry, backing up a step. On Extensa, there's many different ways to do sort of register management. The ESP32 has the windowed option, so it uses a calling convention where the set of registers it can use a sliding window, and then when you call into a function, it will sort of slide that window over. And so it works out that it does that in chunks of 4 registers. And this particular calling convention ends up meaning that because it needs to also include, I think it's the return address, and also I think there's a base pointer, but don't quote me on that. It ends up so that A2 and 3 come in as the stack pointer, and then A2 is the path out again. And so that ends up being pretty handy. I think for a fourth word, at that point, that means you have basically all of the registers free, other than these. Well, you can't touch A0 and A1 either, so otherwise you can't return. So basically, A4 and above are free for use. This is what the transition looks like. It's a bunch of C gobbledygook, but the net result is that you can, if you put in code directly, you can. The bytes for the code directly, you can build up a word. So like this is doing a ×2 where you need to copy over the stack pointer from RDI into RAX, and then it's shifting. It's worth mentioning that in this transition, where normally ESP32 forth keeps the top of stack in a separate variable, it does away with that to simplify things on the assembly side. So the stack is fully based on that stack pointer, and there's no cache top of stack. So anyways, then you're able to shift the indirect value in RDI and then return back. And similar story on Extensa. You do have to have the standard entry. I think the 32 is 32 bytes, and it's doing the shift of the window by four elements. And then here it's using A8 as a temporary register loading in that stack pointer into, loading indirectly through that stack pointer, doing a shift in A8, and then storing it back out, leaving A2 alone. I've also, the dump word previously was not column aligned, and so now if you do a hex dump, you'll actually get things lined up before it would give you kind of a pretty junky dump. It probably still could use some polish in terms of offering a nicer dump, and I don't think it does anything great if you're in decimal mode. So I mean, you can use it, but it isn't particularly readable. So that's another incremental improvement in that regard. Please stop me if there are questions and shout out. I do not mind interruptions. I see there's things in the chat, but ESP32 cam, one of my own projects is I've been slowly working on a set of Wi-Fi connected cameras. The ESP cam offers a version of the ESP32 with a built-in SD card and a camera. So there's a bunch of bindings that have been there for a while to access the camera and capture a frame in various formats. I've made these richer because as I dug into the project and wanting to be able to control some of the dynamic parameters like white balance, I wanted to have access to more of the library. Basically, if you go to the ESP Forth website, this is all documented, but there's basically a ton more bindings. So there's sort of constants for all the pixel formats and knobs for the quality for JPEGs and things to access the buffers and just tons of bindings. So there's nothing sort of substantively different other than that I believe it approaches having all of the bindings that you would need to be able to fully interact with the camera and choose sort of all the different things. And then the last thing I'll cover is something literally got added last night because Peter asked a great question. For a while, you've been able to expand the system using the user words file to add user-defined words, so you don't have to fork the output of the build. But if you wanted to put those user-defined built-ins in a vocabulary, there wasn't really a way to do that. So you would normally define a word, with Y or X. You'll recall Y to if the word is a C identifier and X if it has special characters. Unfortunately, that's the tersest syntax I could come up with. There's a variant of this that supports vocabularies, and this is used internal to the system, but you can it's now feasible to use it inside of user words. It's a little bit confusing. It's not actually directly going into a vocabulary, but it's going into a kind of a weird construct of my own creation called a built-in. And the idea with a built-in is that it's a sort of a magic word that's an extra. Whenever the dictionary scanning crosses that word, it attaches a static set of words that are built-ins to it. So I'll describe what I mean. So, for example, there's this. If you've ever done VList and looked at all the words, you'll notice that there's a word called internals built-ins, or there's a forth built-ins as well. And that word, wherever it sits in the in a vocabulary, if you pass over that word, it will cause all of the built-ins for that type to be searched, and so that allows the possibility of defining a bunch of built-in words, but keeping them largely in flash memory instead of using up RAM for all of their headers, but then preserving the ability to move those words around between different vocabularies after the system starts. So what you would do to use this if you wanted to add words that were not just up in the forth vocabulary is you'd want to add a user-defined vocabulary, or rather than this is, again, a bit of a misnomer, a built-in. So my vocab and my vocab2 would be a built-in. And then you can use the V variants of these words to add those words in to that built-in. And then that doesn't actually create the vocabulary. At start time, you have to actually create the vocabulary and then transfer in the dash built-ins word that has all of those built-ins dangling off of it. I may, please send me feedback on how this works. Part of why the ability to move these around is useful is that the core of the system initially makes assumptions that a bunch of words actually live inside of all inside of the Forth dictionary at startup, and that's because vocabularies themselves are not sort of fully there until they're defined in higher level words, and so it ended up being I needed a way to have words that could be built in that are in a vocabulary, but that start out somewhere that they're reachable. So kind of a bad design constraint on the system that sort of bubbled through to the user. But if you are eager to use vocabularies for extensions, this is what there is right now. That's all I've got for this time. Are there questions or comments on any of that?
Thank you very much. Well, that's actually quite a lot. Amazing. Yeah. And it's really evolving. So are there any questions?
Yes, I do have a question. Brad, why did you choose not to go for ANS word sets instead of vocabularies?
So, sorry, I missed the first part.
Why did you choose to go for vocabularies instead of ANS word sets?
Word list.
Word list, sorry.
So to be honest, originally I was looking for something that I could sort of bootstrap. I didn't have the intention to fully do proper vocabularies originally, and now that they're there, it is a good point that maybe the ANS word lists would be a sort of a better place to land. I think that initially I had an earlier prototype that preceded the ESP32 Forth. I had done an experiment where I was trying to support redefinition of words similar to what Jupyter Ace Forth allows, and Jupyter Ace Forth used sort of old style vocabularies, and at the time I found that amusing, and so as I've used them more, I'm less sure that it's a good pattern, and I'm now beginning to think that the direction the standard evolved in terms of word lists might be better, but yeah, definitely something that might be worth reconsidering. So I guess the evolution was I was using Forth-79 style vocabularies because that I was sort of mirroring Jupyter Ace Forth on a predecessor of ESP32 Forth. Then when I initially didn't have vocabularies in ESP32 Forth, so when I added them, I sort of cribbed from the implementation in that prior version, and then things got out of hand quickly because it became apparent, oh, well, we need all these bindings. I need them in vocabularies now, and soon I was sort of committed in that direction. That said, I do kind of, I think part of what got me exploring that Forth-79 style type of vocabulary, there is something nice about the layering that it does by default. So, but that could be built on top of word lists. Word lists are very flexible, and so, yeah. I don't know if that answered your question.
Yes.
Kristen has one. Brad, when you created the assembler for ESP32 Forth, what did you have in the back of your mind? Because you could do everything in C. What was it that you had to do in assembly?
That's a good question. So in couple different things actually. One is that I am actually a thing that I have found sort of concerning about ESP32 Forth is that and ESP32 in general rather is that there's a lot of black magic in the underlying system, and I've played around a little bit with poking some of the registers that let you manipulate, say, like the I/O ports directly, rather than using the C bindings. But I think that I've been take the Bluetooth stack for example. It's a huge library that takes over half of the the capacity of the system to use it. And so I've kind of wondered whether there's what's going on there. So to be honest, part of my motivation is less that I'm interested in an assembler, but more I'm interested in a disassembler to go poking around in some of the built-in facilities of the system. So that's I think also sort of slowed my progress there, is that I'm trying to build both a dual assembler disassembler. The other thing that I have sort of on my agenda, why I'm sort of interested, is that I've got some prototype of doing machine learning code for on desktop that I eventually intend to try to bring over some small neural networks to the device. And so I have this worry that I'm going to hit performance bottlenecks when that comes. But the other thing is just curiosity. I kind of have been interested in the extensa instruction set. And have wondered, it's not one that I had seen previously in any context, and so I've been interested to sort of learn more. It's a pretty simple, nice instruction in coding, and so it's sort of tantalizing that it's there. But you're right, I think in terms of practical things, being able to extend it in C is probably more practical. But I think it's that allure of, well, if I understood this board better, maybe I would do a pure native forth on it and not rely on the C compiler.
It answers my question. Thank you.
Right. So, are there other questions?
Thanks, Brad.
So, yeah, I can only encourage everyone, try it out and give feedback. So it's actually a system that grows significantly and gets better and better. So that's quite good, and I think Brad is happy about any feedback that you can provide.
Yes, indeed. Oh, and I should say, I forgot now who it was in the meeting that suggested invoking Arduino build, but I've been during the meeting, I've been puttering with that and getting dangerously close to having it work to be able to run the Arduino tools at the command line, and that actually will be a great convenience to me, because it will save me steps in terms of testing it on for the different board variants. So thank you, whoever it was that suggested that. That's a great suggestion. I was able to crib the command lines and sort of tease apart the pieces, and thank you. That was very helpful.
Nice. Right. So if there are no other questions, this concludes our meeting, the formal part. And we leave the conference open for, say, maybe half an hour or so till 7:30 here at this location. So you're free to continue discussing any forth-related issues. Just go ahead. It's getting dark here in Hamburg, and it's dinner time is approaching. So thank you very much for joining, and yeah, I will stop the recording so that you are free to actually talk without fear of being recorded. So thank you very much.